Hi there, welcome to Excellent Scholars Academy. And in today's video, we'll be looking at linear equation of the first order differential equation by integrating factor. Now, how do we recognize a linear equation of the first order differential equation? Now, it's always in the form dy dx plus p of xy is equal to q of x. It's always in the form dy dx plus p of xy equals q of x. So when a differential equation is a linear equation of the first order used by integrating factor, this is how you recognize it. It's always in this form. Dy dx plus p of xy is equal to q of x. Now, p of x is a function of x, y is a variable, then q of x is also a function of x. Okay, so we are going to solve the first question. Okay, so this is the first question we're about to solve. The y dx plus y equals x. Now, the first thing you must understand is you have to recognize your p of x, or you have to make sure your differential equation is in this form before you start anything. So if we take a close look at this, the y dx plus y equals to x is already looking like this, is already in this form. Now if you check it out, if you take a close look, if you compare this equation and this, you notice that here our p of x is equal to 1 and our q of x is equal to x. Our p of x is equal to 1 and our q of x is equal to x. Now, the first step, like I said, we have to recognize our p of x and recognize our q of x. Now, the next thing to do is to get our integrating factor. Now, our integrating factor is exponential integral of p of x dx. Our integrating factor is exponential integral of p of x dx. So the first thing we must get is our integrating factor. So now we are going to get our integrating factor. Now our integrating factor is going to be equal to IF, means integrating factor, of course. So it's going to be exponential integral of our p of x from here is 1. So it will be 1 dx. Now you know that if you integrate 1 with respect to dx, you are going to get x. So this becomes exponential x. So the integral of 1 with respect to dx gives us x. So meaning our integrating factor is equal to exponential x. Now, it is time for us to finally get the general solution to this differential equation. Having gotten the integrating factor, the next step for you to do or take is to get your general solution. Okay, and our general solution is equal to y times this is dot product times integrating factor is equal to integral of integrating factor multiplied by q of x, all with respect to dx. Okay, this is our general solution. GS means your general solution. Y is the y variable, IF is the integrating factor, equals to integral of integrating factor times q of x. Now, finally, let's move to getting the general solution. Having been that we first got the integrating factor, now let's finally get our general solution differential equation. Okay, so now let's move further. So this becomes y multiplied by our integrating factor is exponential x, whereas y multiplied by exponential x equal to integral of integrating factor, which is exponential x, multiplied by, now the next thing we have here is q of x. Now q of x is x with respect to dx. So this becomes y exponential x is equal to integral of x exponential x with respect to dx. Now we have to integrate this. We can only integrate this by parts. So we are going to integrate x exponential x by parts. Now let's quickly do that here. Now, if we want to integrate by parts, we use liat. That's L-I-A-T-E. Now here we have an algebraic function and an exponential function. So which one becomes our u? Because the formula for integration by part is integral of u to v is equal to uv minus integral of v to u. This is our integration by parts formula. Okay, so now we want to integrate this by parts. So what is going to be our u? Our u is going to be our x, because the x is an algebraic function and it comes before an exponential function. Okay, so our u is going to be equal to x, and then our dv is going to be equal to exponential x dx. So now differentiate here. Now you have du is equal to dx, because if you differentiate x you get 1. That's 1 with respect to dx. The 1 is divisible. Now for us to get v from here, we are going to integrate both sides here. So we are integrating both sides. So if you integrate dv, you get v is equal to, if you integrate exponential x with respect to dx, you still get exponential x. Okay, so now finally, to integrate this by part, it becomes that integral of x exponential x with respect to dx will be equal to uv, that's u times v, that's x times exponential x, minus integral of v du. Now our v is exponential x multiplied by our du is dx. So this becomes x times exponential x gives us x exponential x minus, integrate exponential x with respect to dx, you're going to have exponential x plus your constant. But one thing we have to know that the integral of x exponential x is x exponential x minus exponential x plus a constant actually. So meaning that the integral of this gives us, so it becomes y exponential x is equal to, the integral of this from here is x exponential x minus exponential x plus your constant of integration. Okay, and from here, to finally make y the subject of formula, we can divide through by exponential x. Now if we divide through by exponential x, we are going to have finally that y equals, this is going to be x minus 1 plus c exponential minus x. Now how did this become? Now, like I said earlier, we are dividing through by exponential x. The exponential x leaves here, exponential x is here. Exponential x divided by exponential x gives us 1. Then this over exponential x, you are going to be having c over exponential x, which can also be written as c exponential minus x to the power of minus x, according to the law of indices. That's how this becomes this. So, our general solution to that first order differential equation, to this first order differential equation is this. This is our general solution. I hope you understand that. Now you can take the video back and watch this again. You are going to get it because it's actually simple. I promise you. It's very easy. And please make sure you subscribe to this YouTube channel so far. Subscribe to this YouTube channel, like this video, comment and share so that the algorithm could reach others who have issues with this same topic. Subscribe now. Subscribe. Hit that button right now.